I wanted to welcome you on our next online MuleSoft meetup organized by the Warsaw Meetup group. Today will be our main topic, main star is Karol, who will be talking about trade-off analysis, in the EAI architecture. Why are you laughing? You're a star, Karol.
Thank you.
So a great expectations are here. Okay, let's move to the next topic. So our agenda, I mainly talk about it. The first one will be introduction, where Karol and I introduce ourselves. There are no updates from the community, from our local community perspective. For example, from Warsaw, there is not much happening, so nothing. Then we go straight to this topic, deep dive into the composable architecture, and we will have, of course, question and answers. And before we proceed any further, I wanted to ask you to write any questions that you have during the presentation on the Q&A side. It's already open, so you can write at any time the question, and I will be picking up those whenever suitable to ask them to Karol. Okay, let's first ask Karol to introduce himself. Karol, the stage is yours.
Right. So as some of you know, because I see a lot of familiar names in the chat and in the attendees list, I am an integration architect. I used to work for PwC with Patrick as well. I have around 14 years of experience in application integration, started by absolute pure chance as a junior developer with a non-existent company now, Infovide Matrix, which was acquired by Asseco later on. And my first technology ever was TIBCO BusinessWorks. I haven't touched MuleSoft till I actually landed with PwC. Between that, I doubled with web methods, Boomi, a little bit of Solus, a little bit of Azure integration services. Well, at this point, it depends whatever the client has or whatever is feasible. And yes, Adam, TIBCO BusinessWorks classic, right? So I use the version 5 mostly, but also dabbled with Container Edition version 6. So I've been working on and off as an integration architect, enterprise architect. I have a background in development, so I also dabble in development from time to time nowadays too. And I'll be jumping now into Apache Camel for a change, most likely, which is a fun new journey because most of these solutions that I tackled are low-code solutions. And Apache Camel is code-heavy Java. And I never did anything in Java that much other than just a few inputs. Yes, another animal, camel, mule. Yeah, exactly. So that's pretty much it. And in my spare time after work, I devote myself and a few of our other colleagues here also present in the chat and in the attendance. We created a open source educational project about application integration. We're devoting our free time to write articles, create content about enterprise application integration and its architecture in a technology agnostic manner. And as part of this project, I've been doing also an analysis on composable architecture from MuleSoft. What does that entail? What the lovely changes in licensing will mean for us as integration consultants, et cetera, et cetera. Feel free to use the QR codes. The first one leads to the project. There are a few articles published. We're currently preparing more and more articles. The backlog is very, very long because the backlog currently has about 126 positions for articles to be written, and it's constantly growing. So if you'll be jumping into that site from time to time, there'll be more to see and more to read over the next few months, hopefully. All right, that's it from my side. Patrick? You're on mute, man. You're still on mute. That never happened before, right? Yeah, never.
Oh, okay. Sometime I haven't organized. For some time I haven't organized virtual meetup. Okay. Right now I hope you can hear me well. Okay. Let me introduce myself. My name is Patryk Bondurski. I've been working with Karol for, as he mentioned, in PwC. And actually, we were working on the same project, so I've got this possibility to hear his knowledge earlier in practice. Oh, it was very fun time indeed. And of course, still I'm working in PwC. As a MuleSoft subject matter expert, I'm also organizing this Warsaw MuleSoft meetups, and I'm part of the Hall of Fame of MuleSoft ambassadors. Mm, I've been working with MuleSoft products for many years, hard to count, with a very different kind of deployments model architectures. I right now move a little bit from the development into the architectural side. So I moved to the dark side, the dark side of magic. But I like it so far. I really enjoy writing and sharing my knowledge. So I'm a passionate content creator and blogger. And for those who do not know me, from my personal life, I've recently discovered the love of my life, which is paddle, the sport, similar to tennis or squash. I just love it, guys. It's so much amazing. Mm. So I wanted to spread a little bit news about it. Okay. I think that's pretty much it. Now from the introductions, and I will stop sharing my screen and let you, Karol, deep dive into your section.
Okay, so today we will be discussing trade-off analysis within enterprise application integration architecture. And taken as an example, we will be doing this based on MuleSoft composable architecture, which is a very hot topic in the MuleSoft community as it goes right now. Started off a bit of a context. So first of all, we need to demystify a little bit the composable architecture, because it's been a bit of an issue in terms of vague messages from MuleSoft so far. What does that entail? What does that mean? And well, we took upon ourselves to analyze all the materials that we have coming from MuleSoft to see what kind of is under that message somewhere. So the scope of our content study here was the new usage-based pricing model, which is obviously something that a lot of consultants are very concerned about, the impact on architecture from that particular model. And in general, is composable architecture the same thing as composable enterprise, which is something that MuleSoft has been already saying for a longer period of time. I actually researched in the Internet Archive and found that composable enterprise was somewhere around 2017 as a white paper from MuleSoft. So it's been quite a long time already. And does it relate? Well, we'll jump into that in a moment. So first of all, usage-based licensing model. So, and as far as anybody who was using MuleSoft over the last couple of years knows, MuleSoft's licensing model was focused around vCores. So you basically bought vCores from MuleSoft, and then you deployed application consuming those vCores, starting with 0.1 vCore, moving up to 1 or 2 vCores, depending on what the expected traffic, what the consumption of memory is, etc., etc. Now, MuleSoft is moving in part with what the competitors are saying and doing. They're moving to a usage-based licensing model, which means that they basically will be charging not for vCores and not for resources, but per usage. So per deployed flow, which is a fixed price, I believe monthly, and per the amount of messages flowing per that flow. And that obviously triggers a lot of people in terms of discussing, will that cost be actually higher than the costs per vCore? the reason for that, as MuleSoft tries to justify that change, is that they saw the common practice of bundling up several apps into a single deployment over a zero point 0.1 vCore because the traffic was so low in certain situations, certain scenarios, that um, zero point 0.1 vCore was more than enough and it was not busy at all. So there was a common practice. I've seen that many times done over Cloud Hub, that people just bundled up several experience APIs or several system APIs into a single deployment and just deployed as a one unit, which in terms of architectural cleanliness is not the best practice, but in terms of cost savings, absolutely perfect. And it's kind of a trade-off already, right? Something like that, right? Okay, so what does that actually entail? What is the problem we're having with this new licensing model and composable architecture? First of all, MuleSoft in their presentation of the composable architecture and the new licensing model, they shown us several times very vague, unclear guidelines on how to use those specific API-led architecture layers. So we're kind of facing a bit of a lack of cohesion in terms of what are the new guidelines for API-led. Furthermore, a lot of people fear that this will negatively impact reusability, especially in environments where that reusability is highly sought for. And then it will make all the integrations quite a lot more complex, less readable code, less readable repository, less readable architecture in itself. Because if we start dropping certain layers, like an experience layer or a system layer for certain applications, this will probably create some confusion, where by standard, we usually have those layers just because they represented the systems, right? Going on, if we start dropping layers, then the fear is that we will contribute to ecosystem brittleness, and the impact of changes done over our integration platform will be way higher. So we will have to spend more time fixing other applications to accomplish specific changes in contracts, in behavior of the APIs of the main systems, etc., etc. And then more on a soft skill level, we'll have probably, when MuleSoft knocks on the door of existing clients, we'll have some very difficult conversations to have with them about the new licensing model, how to approach it and what to do, and what does that even mean. And the fear is that a lot of our clients will simply abandon API-led architecture due to its cost. That is, in my opinion, a bit of a valid concern, but maybe a little bit too much there. But lastly, some of us who were stuck with MuleSoft for the longer run kind of fear a little bit of damage to their professional image, especially if they were advocating for API-led architecture full-heartedly for a very long time, and they were very strict in adhering to MuleSoft guidelines as they were in previous years. Well, you probably have also other concerns that may be coming from the new pricing model and the composable architecture as explained by MuleSoft. There are probably a different concern per person in this room. Hard to gather them all, but these are the most common ones that I encountered over chatting with several specialists, several consultants that I reached out to just to gather some information. Okay, so let's have a little chat. First of all, what is composable enterprise? Because that has been defined quite clearly by MuleSoft, and it's been around for a longer period of time. So this is actually a quote unquote copy from The Rise of Composable Enterprise, a white paper done by MuleSoft. By the way, Patrick is going to post the links to all the sources that I used for this deck later on. And the sources will be also by the end of the deck written down. And if you have download the presentation later in the PDF format, they'll be clickable links. So don't worry about remembering this at this point. So what we can gather from this definition is that we can have, as a composable enterprise, we have a highly connected organization, which is supported by on-demand services, and they are connected to the enterprise through APIs in a manner of building blocks. So we have this composability trait characteristic dealing here. So we're having Legos in our IT ecosystems, and we're just building new things with reusing the old Lego blocks to build them up and have, right? Which is something we've been doing with API-led architecture for quite a while now, right? So that's actually nothing new. Is that the same case for composable architecture? Well, let me attempt to define what composable architecture is by maybe stating some facts. So first of all, we first heard about composable architecture when the new pricing model emerged, which is coincidence? Probably not, right? So the question is this a marketing trick dealing with product repositioning? Now, I reviewed a few recordings of the meetings that MuleSoft had with consulting companies. I reviewed a few decks that they provided those companies. Thank you all who contributed to making those materials available to me. I was very honest with you, so I could listen in and see what was going on. My deduction from all those materials, reading kind of between the lines, is that this actually is a little bit of a marketing trick. There's really no such thing as composable architecture because API-led architecture is already composable. What it really is, it's exactly repositioning of the product, which is flexibility, not composability. So we're not talking about architecture on its own. We're talking about the flexibility of MuleSoft as a product, which leads us to positioning MuleSoft as a product for API-led architecture, broker architecture, and mass data transfer, which in essence, none of those things are anything new. It's just MuleSoft is saying, hey, our product is great for API-led, but it's also great for broker architecture, and it's also quite good for mass data transfer. And what they're saying is that there are other integration styles. That's exactly it. So in essence, if we would drop the experience layer, the system layer, and we're left with the process layer and apps in the process layer, and they're doing all the work of transformation, orchestration, enrichment, all that within a single app, within a single flow. Is that API-led architecture? No, that's basically broker architecture. And that's what they're saying. Our product is good for all sorts of architectures. And we basically have those two to choose from, where mass data transfer is basically also a broker architecture, only that we're not dealing with single real-time records. We're dealing with scheduled transference of large quantities of data. So with all that, I want to introduce you to a very fancy trick up the architect's sleeve, which I learned from attending here Mark Richards' trade-off analysis, which is a very, very nice way of having a discussion with clients on how to deal with that choice of architecture, among other things. So first, let's land the laws of software architecture, which are quite important here to discuss trade-off analysis. So first of all, everything in software architecture is a trade-off. If somebody will say to you that he found something that is not a trade-off, yeah, they haven't found the trade-off yet. And just yesterday, I had a discussion about that with Mark here. He was with his colleague and partner in crime, book author, on vacation with their families, and they were discussing sitting somewhere nice in Cancun, sipping probably some nice drinks, discussing architecture. And Neil said to Mark that, well, I think everything is a trade-off. No, I can definitely name something that isn't a trade-off, said Mark, and then tried to justify that by giving an example. And the instant he tried to give an example, he realized that has a trade-off. There is a trade-off for everything. So the vacation was ruined basically because the rest of the vacation, Mark was trying to prove to Neil that there is something that is not a trade-off. Unfortunately, everything in software architecture, including integration architecture, is a trade-off. It's just a matter of spotting one. And then the second law of software architecture is why is more important than how. And it's very important to understand why we're doing certain things, because otherwise we'll make decisions that are not informed decisions, or we'll advise our clients to make decisions. And then without that understanding, we could be blamed for giving wrong advice, right? So we need to understand why we're doing things. We need to be able to justify why we're doing those things. And trade-off analysis is something that gives us this lovely justification, this lovely argument in our hand to say, hey, dear client, we can do it this way or this way. Here's what we have for you. And here's why we think we should do it this way. It's your choice, but here's the argument for that. So these two lovely laws of software architecture come from the book Fundamentals of Software Architecture, written by Mark Richards and Neil Ford. If you are interested in upskilling yourself in generalist software architecture, this QR code will lead you to the book on O'Reilly Media. And it's available in a digital format. It's available as an ebook. You can buy it also on Amazon, Allegro, or whatever other shop you're using. I think Mark is currently finishing the second edition, or is it already finished? Haven't checked yet. So quite a good time to get this book into your library. Oh, wow. Mark, thank you. Translated in Polish. Fantastic. We can also read it in Polish if somebody wants to. I would suggest English, but hey, if you want to, that's also fine. Anyways, for the purpose of trade-off analysis, we, in Bridging the Gap, did some research into architectural styles that we can do within application integration. We called them interoperability architectural styles, or ecosystem architectural styles, because they do not apply to a single system. They apply to an ecosystem. And we devised a very beautiful, controversial table, which is exactly this. So what do you see here is an effect of a lot of discussions, a lot of sparrings, a lot of compromises, and being questioned a lot about why, and why. First of all, what is qualitative comparison or qualitative analysis is that, yes, Martin, controversial, yeah. So we can do either quantitative analysis or qualitative analysis. Where quantitative, we can build every single architecture available, measure it, fine tune it, do performance testing, do all sorts of analysis over numbers. And then we'd say, well, this is the best solution. Yes, maybe. But in that sense, we'd have to build all of that, which is extremely expensive, right? And with every single product we have, then comparing products this way would be absolutely ridiculously expensive to do. So what we can do is just sit down and look at the qualities of certain architectural styles and approaches and say, okay, by our experience, by case studies, by observing the reality of our clients, by several other things, or interviewing specialists, etc., we can come by with these characteristics. And these characteristics will point us to, oh, if we do it this way, then this characteristic will be better. Or if we do it this way, this will be better, right? So in this sense, we have a very, very lovely comparison of 5 different architectural styles where spaghetti architecture is a bit of a show that there is a place where we can go where it's absolutely horrendous and absolutely bad. Nobody wants a spaghetti in their code and in their architecture. So this is just to show the difference and put a bit of a comparison there, right? But for MuleSoft, we're not going to be focusing around point to point. We're not going to be focusing on spaghetti because that is not what we're doing with MuleSoft. And we're not going to be focusing on pure event-driven architecture because, well, MuleSoft is not a message broker. It has a message broker in the portfolio of products, but I don't know if anybody ever used only the message broker from MuleSoft to do integrations here. Probably not. So that said, we will be focusing our trade-off analysis only on broker topology and API-led architecture, which are the options we can have with MuleSoft, right? And if you would want to read up on our research in that area, you can have those 2 links. This is our articles from Bridging the Gap on system versus ecosystem architectural styles and how we came up with the qualitative analysis that you just see. And I believe, Patrick, you wanted to pitch in?
Mm, uh, just for a moment, if you could quickly as well, again, recap what a little bit about the broker architecture, as it might be less, less
Right.
known for MuleSoft folks.
Yes, sure.
Thanks.
So, how to put it nicely? If you would think of a broker architecture, architecture is simply a single integration flow deployed as a whole, doing everything, right? So it's it looks more like a workflow than something with separation of concerns like we have in layers in API led. So a broker integration flow would do everything that all the layers in the API led architecture do. A good example of a technology that is a broker architecture would be Boomi. Boomi is designed to be a broker in itself, and all the flows in Boomi are broker-like. Furthermore, they're basically designed to do mass transfer rather than single record requests, but single real-time communication is also available for Boomi if you want to pursue that way. Another example would be, for example, web methods. Web methods is also broker-like technology. If you deploy it according to how Software AG proposes that, then you would end up with a broker topology with a single workflow that does all the orchestration, all the mapping, all the calls to all the systems that are involved in this specific use case of a integration flow. So this is the core of broker topology. And so in essence, like you see, you would see but I covered that the reusability here, the composability of brokers is lower than API led because you cannot really do that much composing in brokers unless you dive deep into the code. So architecturally, brokers are not very composable. Code-wise, libraries, reuse of data models, etc., they are composable in that way. But API-led promotes better composability, better reusability by reusing whole services. So that's the key difference there. Hopefully that answers that question.
Yeah, thanks. It's this context brings me a lot. It's really enlightening. Thanks.
Perfect.
And like Martin said, it's a Boomi style, the broker.
Boomi style. Yes, I absolutely agree. Boomi style. Both me and Martin, we worked with Boomi. So yeah, brokers are definitely Boomi style. And it's a nice technology, but it has its specific use cases compared to the use cases for MuleSoft. So it depends what you want to have with the client and how much budget the client has for integration platform. So it's just a different option for probably smaller clients that we're used to with MuleSoft. Okay. Now we're going to jump into a bit of a case study. So while maybe this workshop is not exactly that much hands-on in terms of code and building integrations in MuleSoft, it is a little bit hands-on in terms of let's put our thinking caps and just dismantle a few things that we can do around integration architecture. I have two case studies for you guys today. Both of them are semi-real life examples. So they've been inspired by actual real life scenarios that I have encountered and some of my colleagues as well over our course of careers. Well, let's jump in. First case, well, meet Malum Medica. So a big pharma company. We're going to be discussing how they are going to be upgrading their interoperability capabilities. So trial run. We have a pharmaceutical company that is in the middle of their IT modernization transformation project, and as a result of several audits on IT maturity, they saw that they need a bit of an enhancement on their data exchange capabilities. So that is specifically for the ongoing and starting drug development processes, drug meaning medicine, just to be clear. These processes are very specific in the big pharma industry, and they're very lengthy processes. So that's quite an interesting use case there. So the requirements from Malum Medica is, so the solution needs to be flexible. So in terms of building logic transformation, and it will be separate for each drug development project. So basically we're building miniature integration platforms per project. And each time we'll have a different scope because each drug will be different. Each drug will be for a different illness, a different sickness, different condition. So they'll have different requirements, business requirements, and basically this is a bit of a problem there, right? So how we look at the requirements, just pausing here on the first one for a second. The requirements we're going to take from a business brief, they could be either functional requirements or non-functional requirements. Those requirements point us either to what logic we build, hence functional, and what are the characteristics of our architecture, non-functional. So a quick shout out in the chat. What do you think? Is this first requirement, is this a functional requirement or a non-functional requirement? Quick vote over chat. Okay. We got it even so far. Okay. Interesting. I spot a heckle here. Okay. So the chat says non-functional. Well, the answer will be in a second. We'll read through and go there in a moment. Okay. Next one, as shown over the years, the integration roles are usually closely related to overarching business processes. That's fair. So the solution needs to support integrating business processes into the integration flow. Patrick, I don't know if that's a good idea because Mark is a jokester. Okay, going on. The integration solutions need to provide sufficient logs as the company is subject to regulatory requirements and frequent audits. How do you think here? Is that a functional requirement or a non-functional requirement? Okay. The majority says non-functional. We'll keep that in mind. All right. There is a limited need for large sets of data to be transferred on a daily or monthly basis. Otherwise, most of the communication is event or on-demand based. Is that functional or non-functional? Okay. There is a clear division. All right. Then next one. There is a strong need for HL7 protocol support. Now this is tricky. Functional or non-functional? Functional. Oh, so many people saying functional. That's nice. Cool. Okay, let's run through the end of the list. We'll get to that in a moment. So the solution needs to be easy to maintain and operate because the company has a very small IT department. So they're relying on external contracts, which is fairly common in our industry. That there are consulting companies coming in, serving as operations, managed services in that sense, and they also offer development. We're doing that all the time right now, right? As in consulting companies. Okay. Further on, a bit of additional context. Due to the long-running processes of developing new drugs, lasting up to 15 years, planning for next stage interoperability is often forgotten. The business just, they're blank out. They're so focused on developing the drug and doing the trials and doing the research. They just forget about IT. Well, obviously, in big pharma, IT is not the core of the business, so why not? As a result, it is nearly an emergency every time a new phase of drug development starts. But fortunately, the volatility of changes, so the amount of changes, the frequency of changes, is fairly low after that emergency is put down by introducing proper integrations. And this is a very common industry oversight. It just happens all the time. And believe me, I've been working with a big pharma company for half a year. I've been bored out of my skull because there was so little work in that period. And the moment I left, there was exactly an emergency like that. So they had to develop new integrations in a very short time just to facilitate a new phase of the drug development. And it's not pretty, believe me. Okay, one last additional context piece. The company has just begun a restructuring process, meaning that the budget might be constrained until this process is complete. Okay, so what do we do with this? If we want to do a trade-off analysis within this business brief, we need to spot which of those requirements are actual non-functional requirements, which will point us to actual architectural characteristics that we can work with, like availability, performance, adaptability, simplicity, etc., etc., etc. Okay. Starting with the most obvious, interoperability. They're looking for a data exchange capability. But hold on. Well, we have interoperability. Those systems need to exchange data, which is, entities, plenty of them. If you go on Wikipedia and type in non-functional requirements, there's a very, very long list of entities. That's the kind of running joke in architecture that instead of calling them non-functional requirements or architectural characteristics, we're calling them entities. Anyways, interoperability. They're looking for better their interoperability in a sense, right? So yeah, that's all right. That's an architectural characteristic. But hey, hold on. We're building an integration platform. Isn't interoperability the functional core of what that system is? Well, pretty much. So in the context of an integration platform, interoperability is no longer a non-functional requirement. It is essentially a functional requirement. We're enabling other systems to exchange data. So that said, I'm going to cross it out. All right. Next up, the integration solution needs to provide sufficient logs as the company is subject to regulatory requirements and frequent audits. Well, that screams auditability because we need to provide proof of what we're doing. But it will also probably go with observability. I went a little bit too quick here. I jumped the gun a little bit. Next up, we have simplicity. And now what's happening here between the auditability and simplicity? So there is a limited need for large data sets, so mass transfer. Again, interoperability no longer is a non-functional requirement. It's a functional requirement of our system to facilitate mass transfer and on-demand transfer, a single record. So it points to nothing in terms of architectural characteristics. Well, not exactly nothing. We could point to performance or something, but it doesn't point in this particular scenario because there are no information over what the volumes are or whatnot. And then again, the HL7 protocol, which is a common protocol for medical use. Again, we're doing interoperability. Our system is dealing functionally with interoperability. In that case, it has nothing to do with being non-functional here. It's just providing that functionality in that system. So we have that possibility to deal with this protocol. And then jumping to the one pointing to simplicity, well, we have limited resources. We need it to be simple because we, first of all, don't want to pay a bunch of money to outsourcing. But also we want to keep it simple because we don't need anything robust, right? Especially given the context that we don't have that much money. So possibly building a larger platform might be a problem. And that maybe it needs to be fast. So the simplicity here is also translating the time to market, right? Then from the same part here, that's the same requirement, we have maintainability. We need it to be easy to maintain. We need it to be easy to get to, look at, look through, do a root cause analysis fairly fast, and we'll have the maintainability on here, right? Okay. Then why we have here contract resilience, right? And notice I have a exclamation mark in front of it, which in a lot of languages means a negation. Well, if you look at the additional context, we have the volatility of changes. And the volatility of changes is fairly low. So that means that our contracts can be a little bit looser in terms of resilience. They don't have to be that refined and that abstracting nature that would give us better control over impact of changes, because we will not have those changes in this scenario. This particular integration will be just built in an emergency mode, of course, but built and then run for the next 4 years or 5 years without any changes to it, quite possibly. Or if there will be any changes, these will be very small changes and very few apart. So basically, zero volatility, very low risk of any volatility of any changes. And the impact will be very low on the systems integrated through this integration platform. So we don't need to go with abstraction layers. We don't need to abstract every single interface and go figuring out how to then connect all of that together. Then time to market. Well, obviously we need to have it very, very, very fast because it constitutes as an emergency every time business just stumbles upon the idea that, oh, shit, we need a new phase. We screwed up a little. We forgot that we actually have IT and you actually have IT systems and we need to, we need to do our processes over computers. Right. They're not done manually. Right. Yeah. We need to collect data, transmit them. Yes. Analytics need to work. Yeah. We need to do it for yesterday. How many times you guys heard that something needs to be done yesterday? I mean, I've heard it several times in my career. So I suppose everybody in consulting heard that at a certain point in time. Oh, you heard that yesterday. Yep. Perfect, Vitaly. Yeah, perfect. Yeah. So yeah, all the time. Exactly. That's exactly the point. All right. So time to market here is important. So we need to develop this very, very fast. We need to have a technology that will enable us to develop very fast, but also we need to have an architecture that will enable us to deliver all the integrations in a very timely manner so that the business doesn't fire us for incompetence. Well, their emergency doesn't constitute our emergency, but they will probably, deal with us, not with their incompetence, right? And then lastly, we have restructuring. Budgets are tied. So we don't have a lot of budget to deal with. We don't have a lot of budget for operations. We don't have a lot of budget for licensing. We don't have a lot of budget for new development. We'll only do what is needed. So that turns into feasibility. And feasibility in essence is cost. But also, do we have talent? Do we have skill sets? Do we have infrastructure? But at the end, it all relates to cost. Okay, so we have those architectural characteristics lined out from this brief. We have some functional requirements. We'll not be touching the functional requirements today. Normally, if we would run this scenario on a architectural kata session, we would dive into functional requirements. We'll figure out the whole setup, how we're going to build the system, draft some diagrams, then write some architectural decision records to show our thinking and our why and how we're going to do things. This is not the topic for today. We're dealing today with only the trade-off analysis. So we're going to base it on our architectural characteristics, which are basically our non-functional requirements. And if you want to know a fun story about non-functional requirements and why are we naming those that way, join some sort of a training run by Mark and Neil. Neil has a perfect story for that. I always crack up when I hear it. So, on O'Reilly, guys, really worth it. So what are we going to do? We're going to take those architectural characteristics and we're going to take our qualitative analysis of these two architectural styles, meaning broker topology and API-led architecture. Okay. So in essence, we have auditability. It's, where was that? Right over here at the end, right? Okay. If you compare auditability, well, API-led is better. Okay. Fair point here, right? Simplicity. Simplicity is about the same. And they're not the same in terms of why they are simple. They're about the same in score. Of course, if you look at the overall architecture, API-led is way more complex than broker architecture. But if you look at, for example, architecture readability, broker architecture is closer in the readability than closer to spaghetti architecture than API-led architecture. API-led architecture is clear. You open up a console, you look at the components, you have experience layer, you have process layer, you have system layer. You know the responsibilities of all of those applications, and you have an app per system or per business domain bounded context, wherever you do with process layer, right? So it's very easy to find which app to start with in terms of doing root cause analysis, pulling logs from, etc., etc. With brokers, these kind of responsibilities are not that obvious. You really need to know your broker to actually say, okay, which process was supposed to transfer customer data or drug test results, or whatever other objects we're transferring. And if you transfer them more than once in different contexts, then it is a bit of a hustle to find the right one, which actually you're looking for in terms of finding the source of truth, right? So brokers are simple because this is a simple unit of deployment per integration flow. right? So they're simple in build. The single unit, the single application, the single flow does everything. There's no layers, nothing, just one flow and we're done. API led on that, in that sense, we have 2 to 4 or 5 different flows over 3 different layers, which makes things a lot more complex, but then a lot more readable. So that's why the score here in simplicity is about the same for different reasons. Well, then let's see. Maintainability. Maintainability, where we don't have maintainability on the list in here because that is a very much an issue of how we actually implement that. And it very differs from implementation of a MuleSoft setup to MuleSoft setup. And with different deployment modes, the maintainability may be very, very different. So we didn't put that exactly in the comparison here. But, well, we can kind of translate this to operational costs at this moment, right? So we already know that operational costs in general for API-led are a little bit bigger than for brokers, given that we have more apps, more to maintain, more points of failure that could go wrong. In brokers, we have a single flow. Well, cost will be a little bit lower. But okay. Contract resilience. As a positive contrary to brittleness, which means that how brittle is our contract, how damaging is a change to our contract. In this sense, we have it negated. So, well, we don't really need it that much to be very resilient. And it's straight up here. Time to market. Well, time to market will translate to simplicity, testability, because if we test it faster with a positive outcome and we can spot what's wrong and fix it faster because it's a smaller deployment unit, well, then testability with brokers is better. And lastly, feasibility, which basically leads us to cost. So let's put a bit of an overlay here. And you see those outlined. We are not interested in this trade-off analysis in other characteristics because we know that these characteristics are the important ones. They're important to our business. Of course, other characteristics will be important, but these are specifically driving our business. These are the requirements of how our systems, our integration platform is to behave, right? So let's say, in terms of cost, feasibility, and maintainability, given that we're outsourcing maintainability, well, broker is a little bit better. Okay. Contract resilience, we already know we don't need the contracts to be very resilient because the volatility is fairly low. Well, broker is a little bit better. Simplicity, they're about the same. And as I explained, for different reasons. And in terms of the context of our company, well, we need it very simple in terms of the deployment and build and time to market, which means that broker here would be preferred. But, well, they score about the same, so let's mark them both, right? Then time to market translated to testability, well, it gives us broker. And then lastly, auditability. We get 5 stars in API-led architecture because it gives us better observability, auditability overall, because we can gather information from more points, a bit more refined instead of specific workflows, which is less refined, and we need to still analyze what the hell is going on and who is producing what messages. So, well, API-led wins in auditability here. Okay, but overall, looking at the characteristics we have, and looking at our qualitative analysis, we look, okay, for those characteristics that are important for us, the broker wins here. The broker seems better for those that are important. We don't need that much scalability here. We don't need that much performance. It's a long process. We have years to do all the things, so that's fine. We don't need extensibility because there's zero volatility in our ecosystem. We don't need composability because the platforms are built per project rather than per company. So we don't really have reusable flows, maybe some code. So composability here is not really an issue, right? And we don't, we really don't need that much abstraction. No, Adam, cost is very important. That's why we're marking cost on the broker side to pay the lower cost. And that's why broker is winning, right? Yeah. So cost is important here. That's why broker is the better choice. So if you would be facing with a new client, a license cost is in the operational costs, basically. But if you look at MuleSoft and the licensing cost, you have less flows deployed in a broker setup than an API-led setup. So that means that licensing costs, given a usage-based model, will be lower in broker than in API-led. Because if we have an API-led flow that is, let's say, point-to-point flow, so we have at least an experience API and a system API, that means we pay twice per flow and we pay twice per message. If we cram it down, all of the logic, cram it down to a single unit of a broker, over an integration flow in a broker, a workflow, so to speak, this means we pay for the flow once and we pay for a message once. Licensing cost is lower in the broker in that sense. Does it mean it's better? Well, depends, like shown in this particular case. So that would be that. So when addressing a client, especially a new client that is about to choose MuleSoft, and the client doesn't really know which kind of architectural style to choose yet, the advice given by MuleSoft to explore other integration styles is basically see if broker is a valid option. Maybe your client doesn't need API-led. Maybe your client just needs a broker architecture. So workflow-like flows. Even if those flows are per single request, so they're real-time or near real-time and on-demand, or even event-driven, because you can do broker and event-driven. So asynchronous communication coming in. So you have broadcasts and or multicasts going through your integration platform just to distribute notifications all over the place. So in that sense, here with this particular case, we'd have a broker.
Karol, I have
Yeah.
a question.
Sure.
Is it, how do you see the case if can we introduce some sort of mixture of broker and API-led architecture? Do you see such case? Like something more fits the broker style, but I'm not sure.
Well,
People like to accommodate, like, for example, we've got as well API-led customers already and
yeah,
they go a mixture.
that's a very good question. So if we would have a mix of those two architectures, I wouldn't really call it a mix. I would rather call it living next to each other. So basically, looking at a setup of MuleSoft and Cloud Hub, if we have business groups and some scenarios in our integration fit more of a workflow, then set up a separate business group to encompass workflow-like flows or mass transfer flows within that group. And then in the other business group, completely separate, do those integration flows that based on composability, that have higher volatility, that need better contract resilience. So they need to be resistant to impact from changes, that they need to be composable, where you can reuse data services from a system layer to compose new process services and expose them to new customers. So the moment you need more reusability, more composability, it would be feasible to go with API-led. And if you have use cases where you completely do not need that composability and it's a completely not reusable, unique flow between two systems, then just focus on the broker-like implementation. And in that way, you can have both architectural styles in a single customer and they live next to each other. And this might be a conscious choice to make, simply.
Okay, just one related to this question. We all already know this lovely diagram of three tiers, layers, experience, process, system. Can we consider such broker processes like kind of we're sitting and living in the process layer of those MuleSoft? Oh, I'm doing a quote with my hands. In composable architecture, for example, some other API-led services could reuse this kind of process. Does it make sense what I'm telling, or?
Yeah, I understand what you're asking. Would that make sense to have this as a process in a process layer? Given that your workflow like flow is
Mhm.
basically doing everything, transformation, like experience layer and system layer, it's doing orchestration, enrichment, then I don't think it's as feasible that this actual broker-like implementation would be reusable. Probably there is very low chance that it would be reusable anyhow. If anything, it's like Munchin is suggesting in the chat that would be reusable on the level that you have experience layers calling it, but you will not have any system layer applications connected to it anyhow. My suggestion would be to keep them completely separate and do not force broker-like flows into the API-led architecture naming conventions. So while a broker flow would actually fit in the process layer, if we want to force it in there, I would keep it clean and completely separate them. So if we do an API-led architecture, put them in the API-led naming conventions, put them in their layers. If we're doing brokers, avoid naming them process APIs, avoid naming them experience or system APIs. They're brokers, they're workflows. They
The API now, right now, MuleSoft is right now shifting to calling the layers not APIs, just the layers, like experience.
Yeah.
And for example, controversial maybe to you, I'm not sure if you've seen this. For example, MuleSoft started putting external stuff on those layers. Like for example, Salesforce flow, which is kind of workflow, into the process layer. Have you seen this kind of image? It blew
Oh,
my mind.
okay. That's something I would ask you to share it with me later after this session, because that would be another interesting thing to maybe discuss some other day.
That's why I'm asking about this, as it's kind of felt for me similar.
Now to give you that, uh,
But I will share this.
what MuleSoft says, I saw that over several recordings and several slide decks. They would actually put the broker workflows into the process layer, so that doesn't really surprise me. Uh, but yeah, that my advice is keep it separate. Do not try to foresee future whether or not the broker will be anyhow reusable, because that may not have any sense there. If we're deciding to design a broker-like architecture and have those workflows working there, make that explicit that they're not going to be very reusable. And that makes it a little bit cleaner and better. All right, but we still have more. So let's move on a little from this case number one. We have case number two, HR Solutions Norway and their product Amplify. Okay, again, we'll dive into the business cases. Pretty much the same similar setup as in with case number one. So we have a bit of a brief, requirements, and additional context. So we have the company HR Solutions Norway, and they have a SaaS offering, a product Amplify, that is an HRM platform. If you're familiar with Workday, Workday is basically an HRM platform. They have been developing this product for a few years. They started as a very small company. They have grown to a medium-sized enterprise. Due to the product's functionality growth, the HR solutions, they're looking for and operate in data exchange capabilities of their ecosystem and product, right? So let's take a look at the requirements. The solution needs to support information exchange in a globally distributed environment. All right, that's our game, right? New systems and applications need to be easily integratable into the ecosystem, as the new functionalities often are a result of acquisition. Now, who can guess what kind of architectural characteristic this would be? Because this screams an architectural characteristic here. I know Mark will definitely scream out loud one. Yeah, exactly. Mark, don't spoil the fun. All right. Okay. Anybody else? Well, Patrick spot on. That's extensibility. Exactly. Mark, come on. All right. The solution needs to be easy to monitor to provide audit proof if needed, as the SaaS offering may be subjected to various buyer and government audits. Okay. The solution is required to provide orchestration capabilities that can be further used down the line to build new business capabilities. And additional context for this particular company, we have a few of the backend systems offering acquired earlier, and they were flagged by a recent audit as vulnerable and non-compliant with regulations. And there are so many regulations in the HR world that they need to follow that is ridiculous. GDPR being only one of them. And if you span globally, there's so many more than GDPR to tackle. So HR Solutions, they decided that it's actually cheaper to replace the components completely rather than rewrite them and refactor them to meet the compliance standards. So they're acquiring new software from the market. They're buying companies, they're incorporating those companies into their structure and just putting those blocks of code, those apps into their ecosystem and hooking them up to their product. Okay. And the company has just landed a few new contracts with clients that are located in Europe and Asia. Oh, there's a little bit of that there. So again, we have interoperability, main characteristic here, but interoperability is our game. We're dealing with interoperability functionally. So like earlier, cross down. Then good guess here. We have extensibility, only that, I'm sorry, the arrow is actually pointing to the end of the arrow is pointing to the wrong bullet point here. It should point a little bit lower. So that was extensibility. Then we have observability. We need to monitor and provide proof for audit for several audits from buyers or government. That also screams auditability, right? Then we have composability. We need to compose our, by orchestration, the solution needs to provide us to build new capabilities for our applications, for our product, from the data sources that we have, from the services that we've already built. So we have the composability trait. Further on, now we're buying from the market. We're having completely new apps joining our ecosystem. Those apps are written in completely different languages than we already have. They have completely different data models. Those data models do not agree with the rest of our ecosystem at all. Well, if we would have broker-like integration flows, that might have been a problem. We need a little bit of that abstraction here. We need to hide those specific changes of the data model, especially if we're replacing another component. We're not just incorporating a new one, we're replacing it completely. So we already have a system layer with an app there. We already have some integration established to the previous system that was in place. So we need to abstract, right? because we want to encompass the new one. So we want the abstraction to hide all the impact of changes. So instead of changing the whole integration flow, we'll change only the system layer application. All right, moving on. We also need the removability characteristic, because obviously if we don't have that removability, we'll not be able to just pull apart our ecosystem and put in new apps in place of those existing. And lastly, geo-redundancy. Now, going to the next stage, what do we do with those characteristics? So we have our lovely qualitative analysis table again. Let me put on the mask for those particular characteristics. Okay, so we have abstraction, contract resilience, composability, extensibility, observability, and auditability. Now, contract resilience here is in terms of removability and also a little bit tying down to abstraction. We need that. We need to have that so that we don't break our integrations, existing integrations, especially with replacing the apps entirely, right? So that is a bit of a problem that we need to deal architecturally. And let's look at this. Okay, so we have extensibility, 4 stars, composability, 5 stars, abstraction, 5 stars, contract resilience, better in API-led, observability, auditability, way better in API-led than in broker architecture. If we start marking, you'll see that all the important characteristics we had in this particular business scenario will be on the right side of API-led architecture. So by looking at the trade-off analysis, what we're gaining, what we're losing, knowing the qualities of our architectural styles, we can say to our client here, dear client, with your business profile and the way your business behaves, the way the things that are happening within your business, the things that are important to you, we would suggest not to utilize broker architecture, but go straight to API-led architecture, because those qualities will be better with API-led architecture. You'll have faster time to market. You'll build better, resilient, and more maintainable integrations that way, instead of doing a lot of changes every time you replace an app or every time you add another one to your ecosystem. This way, you can actually make it a lot smoother. And, the superpowers of API-led that you guys already know about because you do MuleSoft, right? So this is the result of a second case, right? We have specific scenario. We have a completely different business, or a little bit more fast-paced, also subjected to audits, also subjected to providing proof, but completely different in that sense, right? And that way we can provide some more details. Okay. Looking at a bit of a summary for our case study. So in essence, what MuleSoft is saying, we have API-led architecture and we have broker architecture. Both of those are valid approaches for our clients. We need to pick them contextually. Second of all, we need to do due diligence with our customers as consultants. We need to do discovery, and we need to do the analysis of their business. We need to figure out what they're doing, how they're behaving, look at their track record, at the history of acquisitions, look at all those things that might be relevant. This is context. These are not their requirements. This is not what they say they want. This is something that they do, which speaks more than what they say they want. Because those things might point us to very important factors that we might as well miss. And this may be the downfall of the integration project, because those were missed because nobody did that due diligence. And that happens. A lot of old-time ESB projects fail due to those kind of this kind of situations, this kind of context not being taken account for. So better we understand the client, the better our integration solutions will be in that sense. So a bit of predictions there. If you guys have customers that have API-led architecture, and you fear that due to the new licensing model, if they're going to switch, they will abandon API-led architecture, that's not going to happen. Because moving to broker architecture, this is a migration project. If your customer has already invested hours, hundreds of hours, hundreds of thousands of euros, dollars, Polish zloty, whatever the currency is, into building an integration platform, an API-led architecture, that means they already have a lot of integration flows. If all of a sudden they'll figure out, oh, the new licensing model, well, we need to start cutting corners. No, they will not, because the migration to a broker architecture will be very costly, because they'll have to glue together experience layer, system layer, and process layer into a single entity. And that's not that easy. It may seem very easy, but it's not as easy as it seems. It's going to be costly. It's going to be time consuming. It's not going to be fun. It might turn out to be an endeavor way more costly than paying the new licensing fees. Really. All right. If we look at new customers, it is very true that new customers looking at the pricing model will probably choose the broker architecture. And I think it is important for all of us as MuleSoft consultants to embrace that broker architecture, to find what it is all about and how to standardize that, break some standards, and deal with that. But I have one more thing for you guys, a little bit of a bonus case. API-led architecture layers, right? Should we remove them? That's the big question that people meeting composable architecture and all the marketing stuff around the new licensing model have in mind. Should we remove those layers? Should we actually do something? Should we actually compromise our standards? That is a very problematic question for the MuleSoft community right now. And I've heard so many people having an issue with that. And I do understand that is problematic. Okay. Pardon me for the diagram. It's not in the MuleSoft naming convention. It's our own from Bridging the Gap. Let's have a bit of trade-off considerations. We're not going to do a trade-off analysis here, because for those layers, you need to have very specific use cases and you need to analyze all the use cases. So I'll give you some considerations, what we can do with dropping or not dropping those specific layers. Now, you already see that I dropped the process layer here, and that's a common practice in the industry. We've been doing this for years. If this is a pass-through, if there is no logic in the process layer, drop the process layer. I think that's a standard for everybody. We've done that so many times over the years. Nobody is going to question that, right? But considerations. Single point system boundary. So with API-led architecture, every system has a single point where they connect to the integration platform as a consumer of the platform, of the services, and they have a single point where they are the provider, and they connect through the experience layer and they provide through the system layer, right? That is an important consideration. If we drop those layers, then there may be multiple points, which might be a bit problematic. Configuration management. If we suddenly stop dropping system layers and system applications and those services, that means that other services will have to pick up the configuration management for that particular system. That might be very troublesome. That might not be fun at all to maintain and deal with. With brokers, that might be a little bit simplified. With that many apps in the ecosystem, that might be very confusing and not very clean. Well, given that this diagram is just a very small subset of applications we may have in our ecosystem. These are just 5 systems. We usually deal with 20, 30 systems in a API-led architecture or even more at times. So this is a small subset, right? So configuration management might be problematic. Replacing credentials for a system in several applications where because the system refreshed their credentials or they had the breach and they just reset client secrets for everybody. Whew, that's a challenge. Somebody might miss something unless you actually have a robust configuration management solution that you can automate that. Well, not all of us have that. So that's a bit of an issue to consider. Model coupling and security. The very important thing that those abstraction layers do for us, especially with event-driven architecture, they provide a bit of a safeguard so that we don't come into model coupling. Because what is happening here, this system may expose that the provider system, they may expose their data model directly. For example, if we're connecting directly to a database, and I know this doesn't happen that often anymore, but sometimes it does with extremely legacy systems. They're exposing in that database, usually their data model. Not all that the database experts are aware of encapsulation for an integration user. They don't provide a separate schema. They just let you into their main database. And that's a bit of a problem. So if they do that, they expose their data model outright to your integration layer, right? So if we have a system layer in the mix, that means we are a little bit safer in terms of model coupling because we can do just contract coupling because the system layer will hide that internal model and expose the REST API, most likely in front. So we'll expose an open host service, which will be safer. It will hide the logic of accessing data in the system, right? So this will be a little bit more secure. Furthermore, if we are doing broadcasts over topics, so a pub sub pattern, if we don't have our system layers to abstract the message, well, we're giving everybody exactly the same message. What if that is a definition of an employee and the employee data, which are, extremely, let's say, fragile data in the eyes of GDPR, right? We don't want all of those systems to get exactly the same subset of data. We want only some of that data to the extent that that system uses, not all of that data, because that may constitute as a security breach. If somebody would access logs for this data, that might be problematic, right? So the system layer provides an abstraction of that data. It cuts down that data and hence makes our communication safer and our systems safer from breaches and coupling. I already said about system access logic when I described the database scenario, right? So we're hiding that logic within the system API, but also we're kind of hiding that in the experience layer. Also model coupling, if we return a response on a synchronous service, we're also cutting it down sometimes to the extent of the response that system needs. So basically we're hiding a specific logic, we're encapsulating that. And then observability and auditability. If we need robust observability and auditability, because we need to know exactly who is using services, especially services that are commonly reused. So we have, for example, 5 or 4 clients accessing the same data service. Well, we need better observability and auditability to keep track of usage, to keep track of who's asking, to keep track of anomalies, etc., etc. So that's something to consider. Handling traffic policies. Okay, that's a tricky one, right? In MuleSoft, you have an API management that's basically API management that's basically deployed with each and every app. So you can tweak policies however you want on each layer, which is wonderful. If you have a broker style, you can tweak on the entrance of that particular integration flow. That's kind of it. in terms of the integration platform. Then you have to tweak that on the systems. And that gives us less maneuverability over how we can tweak traffic, how we can deal with peaks of traffic, how we can deal with all sorts of throttling, SLAs, etc. Right? So if that's important for our clients, don't drop the layers. If that's not important, mate, fair game. We can try and drop some layers and see what happens. Right? Reusability. I think by this time in our presentation, reusability is very obvious here, that if we have API-led architecture as we did it so far, we'll have better composability, better reusability. If we start dropping certain layers, we will not be able to compose those services as well. We'll have those systems exposed. Yes. Will that be composable, reusable? Might not be, just due to the fact of the volatility of the system. That might be troublesome rather than reusable. Caching considerations. Well, we can implement a cache on every single level, every single layer here, depending on what the use case is. We can have a cache on the service, so we don't overwhelm all of the systems underneath that service. We can have a cache on the data service on the system layer, because that particular data service is accessed more often. Or we can have the cache on a experience layer, because that is accessed more often by that service is accessed by that specific system very often. So instead of doing it somewhere further down the line, we can do it here, because other systems that ask that service that often and they can just call whenever they want, but we want to safeguard our systems, right? So this is the consideration to be had here in terms of dropping specific layers also. And that is the last one I had for you. Probably there are more. These are all that I could have figured out from my head. Probably some of you clever chaps will figure out another one that could be very handy to propose to your client. Hey, what about that? I urge you to think about it, because that is important in the discussions you might be having with your customers about switching between broker or choosing broker or API-led or dropping specific layers. Now, lastly, a bit in summary before we wrap up the presentation. So, advice for our architects in the session: you need to prepare to have those difficult conversations. They will be difficult. They will be not comfortable. You need to be prepared. You need to understand what is at stake with composable architecture. So revisit how you understand your client. Revisit what you know about their business. Revisit what you know about their business behaviors, acquisitions, adding new software into the ecosystem, volatility of changes, whatever that may be. Just listen to your customers, try to find out. Translate the business to architectural characteristics. So like we did with the business briefs from Medica and HR solutions, just look at that, what you know about your customer, try to translate to architectural characteristics. See how you can work with those architectural characteristics. See which architectural characteristics are important to you. You can use our qualitative analysis table with the star rating of different architectural styles. If you feel like you want to challenge it, feel free to challenge it. Feel free to tweak it to your understanding of those particular architectural styles and use that as a comparison between those two styles. Chat with your customer. That is a valid approach. Everybody has a bit of a different view on architecture, and there is no correct solution. There is only the least worst solution, right? And then check if those architectural characteristics and what you know about the business and what you know about the current implementation of architecture, does that actually match? Does that actually brings together to a cohesive view, helicopter view of their IT and their processes and their integrations? If not, there might be an opportunity there to do some actually decent work that will help their client. the client, right? So look at it, be honest with your client, and just have those conversations. And further on, advise the clients by giving them proper insight. Now, a little bit more, learn about broker architecture as you did with API-led architecture. Perhaps it would be a beneficial thing, and don't uh, don't go shouting here. Learn a different a different integration technology just for comparison, just to get a feel how they implement brokers. Boomi was an example here given several times. That is a good example of a broker technology. You can learn Boomi for free, and then just come back and learn and take what you learned from Boomi and apply it in the MuleSoft ecosystem to build brokers, to build workflows. And that's an absolutely fine approach. The more you know, the richer your expertise is. So the better your MuleSoft solutions will be in hand with that. And one of the last ones, create standards, right? So we already have standards and we have guidelines for API-led architecture. Those guidelines and standards will be very different for broker architecture, especially when it comes to coding broker architecture, to building those integration flows. They will not be like API-led flows. So have those standards, figure them out, work on them, and you'll be just perfectly fine with the new world and how MuleSoft markets their product. Okay. And as I promised, this is the bibliography that I used to produce this lovely session. Quite a bit of content. First off, as you see, the white papers from MuleSoft on composable architecture, those dates are actually from the Internet Archive, where they did index those particular white papers. So Composable Enterprise is already quite old. And then a few more that are, in my opinion, pretty useful. Feel free to reach out for those. I think Patrick is supposed to paste those links in chat for you to have. Otherwise, they will be available in the PDF after the session. And thank you for your attention. I think that's been a fun session to have. Visit me on LinkedIn or visit our page, Bridging the Gap. There will be more content coming to Bridging the Gap over the next few months. We're constantly working on producing more and more. Hopefully, you'll find something of use. Thank you.
Thanks, Karol. I think we can, I will share the screen. I think we can move to the question and answers. I mean, there is not yet a lot of questions, but still, Karol, before we move on, thank you very much for sharing. Oh, I'm unmuted? Yes. Thanks for sharing your insights in this MuleSoft composable architecture, the trade-offs analysis. It was very enlightening for me, as well as when I mentioned that I've started shifting my to the other, shifting to the architectural side. It was very pleasant to hear this. And I think we'll start with the first question from Vitaly. He wrote on the chat, what is the difference between point-to-point and spaghetti that makes them as separate types of analysis? Yeah.
Yeah, that's a very good one. So we found during our research that point-to-point is absolutely fine. If you want to do point-to-point in your ecosystem, well, we'll probably not be there to see that. We'll probably come in when you already have spaghetti. But if you're designing a small ecosystem, a few apps interconnected, point-to-point is absolutely a fine choice. The difference between point-to-point and spaghetti is that if you, at a certain point, stop managing your point-to-points properly, and you just build and build and build and build and build and apply no governance to that, you end up with a spaghetti architecture. And same goes to coding, like in Java or C or whatever other language. If you just start building on top of everything, you get the so-called big bowl of mud, which you don't really know what's happening. And a simple change in one place impacts a cascading change everywhere else. And that's pretty much what spaghetti architecture is in terms of interoperability. So the only difference really between point to point and spaghetti is the scale.
True.
Hopefully that answers that Vitaly's question.
I hope. Shout out Vitaly if it didn't. Um, okay, there is a question from Adam, I see.
Okay, perfect.
Uh, I wonder about the star dollar table of yours. Can those value allocation differ based on the different factors? For example, maybe for some processes broken might have a better observability.
Yeah, the table, the qualitative analysis is very generalized. It definitely will differ from implementation to implementation, depending on various factors. Just looking at IT maturity or organizational culture. If you're not familiar with something called Conway's Law, just Google that. Uh, it's a very old one. I'll write it in chat so you know what to. There is actually a described law. I think. Correct me if I'm wrong, Mark. Mark knows that. That's somewhere from the 70s, I believe. Conway described how organizational structure impacts systems and development of systems and development of architecture. And that is still very true. So if we have a distributed organization and we are not aware of Conway's law, that will be a problem. If we have teams that are not cooperating, that will relate back to our architecture. So it will differ per implementation. It will differ per client. It will differ per company culture. It will differ per used approach. Is that wonderful? Is that agile? Is that domain driven design? Whatever the approach to producing software is, those ratings will definitely shift somehow. But we produce that by a little bit of a generalization of our experiences and observations from the industry. So, of course, you could challenge that. Of course, you will have a very different perspective on certain things. After discussing some things, you might agree or still disagree with me on the scores given in the comparison, in the qualitative analysis. And that's perfectly fine. That's just what it is. That's our research. And we use it to help ourselves and help others understand the differences. Of course, it will differ. And Alexandra, yes, system design and organization tend to repeat organizations' communication patterns. That's exactly Conway's law. Yeah. Yeah, and if we apply scale to it and just divide the cost by scale, as you mentioned, Adam, yes, they will differ, but in terms they will be kind of proportionate still to a certain extent. But either way, they might differ depending on the technology used, the licensing costs. If you use open source technology, the costs will be lower. If you already have people knowing specific technology or a programming language, your costs will be lower because you will not have to train those people. You will not have to acquire talent from market. Uh, there are so many factors that can come in to reshape those scores that it's a bit crazy to discuss them at certain points. But yeah, we made a generalization and we're very open about this, that this is a generalization and that's what it is. Take it or reshape it, however you want it.
Perfect. Still, I encourage all of you to ask the questions to Karol. Feel free to use Q&A chat. In the meantime, I've got question to Karol.
Ooh,
Again, I was reviewing some slides from MuleSoft,
okay.
and uh, there I noticed some their advices where to opt out from, for example, system API layer,
Mhm.
API in the system layer. Like for example, they gave example with, for example, Salesforce. They
Oh,
as a Salesforce connector that they provide, MuleSoft provide basically, provides high abstraction and hides all the complexity details behind the Salesforce APIs. Those of you who work with this know how directly know how complex it is. So their advice was to, for example, skip this and use this. How do you see it? I think your trade of points actually gave me some idea, but I wanted to
yeah.
know your thoughts.
Yeah, I mean,
It depends.
yeah, it depends. That's the most
True.
general answer I can give, and we would have to have more specific details on the use cases, and especially what is important to your customer.
Mhm.
So, just looking at the list of trade-off considerations that I put for removing layers, uh, mm, probably if most of them are not that important for your customer, I mean, yeah, skip it. Why not? But then again, if you are concerned about the scale of your integration platform being a lot of components and a lot of them relying on Salesforce per se, that means you need to duplicate configuration for Salesforce all over the place. There will be probably several process layer applications that will be connecting to Salesforce, right? So that means you need to duplicate all of that config to all of those process applications, which is impacting your maintainability, your ability to operate your platform, right? Uh, then handling traffic policies, you can no longer handle traffic solely to Salesforce. And we know that Salesforce has specific licensing limitations on traffic, incoming and outgoing traffic, right?
Um, and someone might correct me if I'm wrong, but MuleSoft with Salesforce introduced these capabilities that's the usage of Salesforce connector is affecting the way how the limit is limits are counted. It should be more mm, like
Efficient.
efficient from licensing perspective to use
Oh,
connector.
say there you go, another trade-off. If you use the connector, you get less usage countdown from the
Yeah.
license. Okay, then yeah, then considering how much traffic you have, that might be a viable option to consider as another trade of consideration there to drop a system application for Salesforce. Um, Another one might be observability and auditability. If you deal in Salesforce with data that you need to govern well, and your security is very interested in what data is consumed from Salesforce through the connector, it would be more feasible to implement observability and auditability features in a system layer application rather than all of the process applications, right? So it, it, there are so many factors, and this will be very different for each and every use case you have. It's very hard to say drop or no. You have to actually sit down, analyze the considerations with your client, with your business analyst, look at the BPMN diagram if you have one, and just consider what to do with this and when. And there is no generic guideline we can follow on that, only that you need to do your due diligence and figure it out and make a decision and make an informed decision by doing that due diligence, right? And that's the only advice I can give that is actual advice.
Yeah, actually, the list is a really good advice of yours. Like, I can go through from this and thinking about the trade-offs as possibilities from this perspective. So it's a very good starting point, I would say. And moving smoothly to the next question. I think interesting question asked Adam if we are skipping experience API, and are we actually making? Does this make the process API actually a broker? Uh, Um, yeah, I think I
Uh,
will kind of could answer, but
I
Chantal, go
think
ahead.
that the question meant was not ex-API and PAPI, but ex-API and SAPI. So the
Yeah, yeah, I
system
thought so.
system app. Uh, yes, that actually is very true. If we just leave a process application, and I already said that when we were discussing the removing layers slide, that would actually make the process app a broker, a workflow. Yeah, uh, absolutely. Uh, so why would we keep it an API-led architecture if we remove the experience layer and we remove the system layer for that particular process? Uh, well, yeah, just name it a broker and let's be done with that. And just not play around with forcing the API-led structure onto that. It makes very little sense to force that.
True. There was another question from Alexander about your rating for broker integration in area of observability, and the question was why it was uh,
Lower.
low. Yeah,
Yes, that is a very, very good question. Really, I like it. So the reason being, if you have a broker and you have a workflow as an integration flow, this integration flow handles everything, right? So basically, it handles all connections to all systems every single time. Your log file, if you run it in several threads at the same time, is basically a very long list of executions cut through different threads, right? Very hard to read. Of course, you can automate that to make that clean and etc. Not exactly the nicest thing to do. While if we implement observability over API-led architecture, and especially when we have a lot of composability and reusability, then we have a very fine grained classification of what is what, because we see the request coming in through an experience layer. So we know that this particular client requested. And we see all the requests going through the system layer. So we can easily classify, count how many requests were done to this specific service in this specific system, which makes the observability topic a lot smoother because you can more easily pull out metadata that would be very useful in classifying that over OpenSearch or Elasticstack or whatever you're doing to aggregate your logs. While when you're having a workflow, this would constitute with a lot more planning and a lot more robust implementation of logging. So you can pass that metadata and specific markers that you're actually invoking an API of that particular system in this particular workflow. Here it's done by default by the name of the application. You have a name of in the system layer, you have the let's say Salesforce SAPI. Oh, you perfectly know you're invoking Salesforce. You don't have to figure it out. It's in the log. It's in the metadata by default, right? If that would be a workflow in a broker architecture, you would have to deliberately mark it every single time in your log wrapper. So it's a added complexity on the code that makes it a little bit harder to design for observability. And you need to be more deliberate about doing that observability. While you can reach the same level of observability in terms of gathering data, there is more effort with broker architecture than API-led architecture to do so. And that is why its score is lower. Simple as that. All right.
Any more questions, guys? I can't see any more.
Yeah, I scanned through the chat and the Q&A. I think we're done. That's that.
Okay. Okay. Uh, cool stuff, guys. Okay. Oh, it was really cool. Thank you
And
again.
amazing questions. Thank you so much for the questions. They were really good.
Yeah, they was really good. Thanks, Karol, for delivering this presentation. Like someone said, no one asked, but everyone needed. I love it. I love it.
I love that comment.
True. It was eyes opening, the ways that you introduce how to um, think about the composable architecture in the context of the MuleSoft currently. And yeah, there was quite a lot of interesting questions, which I love. Um, yeah,
Absolutely.
I think we can wrap this up. And thank you everyone for joining, and have a lovely rest of the day or the evening. Thank you. Cheers, everyone. Bye bye.